Welcome to DDevOpsAcademy, your gateway to mastering shell scripting. Whether you're just starting out or looking to sharpen your automation skills, this course is designed to make scripting simple, powerful, and practical. Join us at DDevOps.academy and take the first step toward becoming a DevOps pro. Let's break down what a shell really is. In simple terms, the shell is your gateway to the operating system. It lets you interact with the system either through commands or graphical tools. If you're using Linux and typing into the terminal, you're already working with the shell. Think of it as the outer layer around the kernel, which is the core of the OS. Before diving into shell scripting, we need to understand three key components: the kernel, the shell, and the application layer. Talk about the kernel, the heart of any operating system. It controls everything: files, processes, memory, devices, you name it. In Linux, the kernel is what Linus Torvalds developed, not the entire OS. The full Linux system includes the kernel, GNU utilities, and other scripts that make it usable. Understanding the kernel is key to grasping how Linux really works. Explore the shell a little deeper. The shell acts as a bridge between you and the operating system. It takes your human-readable commands and translates them into instructions the kernel understands. Shells come in two main types: command line shells, like the terminal in Linux or command prompt in Windows, and graphical shells, which offer a visual interface. When you log in or open a terminal, the shell is ready to serve. This is what shell interaction looks like in action. When you type a command like ls-l in the terminal, the shell interprets it and communicates with the kernel to fetch the result. Here, we see a detailed listing of files and directories, showing permissions, ownership, size, and modification dates. This is the power of the command line shell: precise control and visibility over your system. Graphical shells make computing intuitive. Instead of typing commands, users interact through windows, icons, and menus. You can open, move, and resize windows, all without touching the terminal. Systems like Windows and Ubuntu offer rich GUI environments, making everyday tasks accessible to everyone. What you see here is Ubuntu's File Manager, a perfect example of a graphical shell in action. There are several types of shells in Unix and Linux systems, each with its own strengths. The original Bourne shell, or ESH, laid the foundation. Then came Bash, the Born Again shell, which is now the default on most Linux and macOS systems. C shell, or CSH, offers a syntax familiar to C programmers, while Z shell, or ZSH, brings modern features and customization. Bash remains the most widely used, and yes, it even runs on Windows. Shell scripting lets us automate repetitive tasks. Instead of typing commands one by one, we write them into a file, called a shell script, and run it whenever needed. These scripts use the .sh extension and follow a syntax similar to other programming languages. If you've used Python or C before, you'll find shell scripting easy to pick up and incredibly powerful. A shell script is more than just a list of commands. It's a structured program. It includes keywords like if, else, and loops, along with standard shell commands like cd, ls, and echo. Why use shell scripts? To automate repetitive tasks like backups or system monitoring. They're fast to write and easy to debug. But be cautious. One small mistake can cause big issues. Shell scripts aren't ideal for complex logic or large-scale applications, but for quick automation, they're a powerful tool. Let's look at a basic shell script in action. This script prompts the user for their name, reads the input, and greets them. It's saved with a .sh extension and executed in the terminal. Notice how we assign command output to a variable using UMI equals open parenthesis cat anyfile.txt close parenthesis. Shell scripting is all about combining commands into reusable automated workflows, simple, powerful, and efficient. Let's explore decision-making in shell scripts. The if-else example checks a user's age and responds accordingly, perfect for eligibility checks. The case statement, on the other hand, handles multiple conditions more cleanly. Here, it identifies nationality based on the country input. These structures make your scripts smarter and more interactive, just like real programs. Let's dive into for loops in shell scripting. They're perfect for repeating tasks. In the first example, we loop through a list of elements. The second counts from 0 to 3. The third increments by 5, great for custom ranges. And the fourth loops through an array of book titles. These loops help automate repetitive actions with just a few lines of code. Let's wrap up with the while loop. Unlike for loops, while loops run as long as a condition is true. In this example, we start with I equals 0 and keep printing numbers until I exceeds 2. This gives us fine control over loop behavior. Whether you're using brace expansion or conditional loops, Bash scripting makes repetition simple and efficient. Let's explore two powerful shell scripting tools: file reading and regular expressions. This loop reads each line from /etc/passwd and prints it, perfect for processing system files. The alias example shows how to create shortcuts for frequent commands, and with regex, we can match patterns like lines starting with A using grepsi. These tools make your scripts smarter, faster, and more flexible. Sed is a powerful stream editor used to transform text line by line. Its most common command is substitution, using s/old/new/g to replace words. But watch out for slashes in your values, like URLs. In that case, change the delimiter to something like plus to avoid errors. With regex support, SED becomes a flexible tool for editing files and automating text manipulation. In shell scripting, special variables give us powerful control. $0 holds the script name, while $1, $2, and so on represent input arguments. $$ tells us how many arguments were passed, shows the exit status of the last command, great for error checking, so gives the current process ID, and tracks the last background process. These variables make your scripts dynamic and responsive. Let's practice creating an SSH user with a shell script. This script checks if the current user is root, prompts for a username and password, confirms the input, and then adds the user, only if they don't already exist. It even encrypts the password using Perl before creating the account. This is a great example of combining user input, conditionals, and system commands to automate real admin tasks. This script is a secure way to create SSH users on a Linux system. It checks for root access, prompts for a username and password, confirms the input, and ensures the user doesn't already exist. If all checks pass, it encrypts the password and adds the user. It's interactive, safe, and ideal for system admins automating user management. Let's walk through two essential DevOps tasks. First, deploying an HTML site with NGINX. We update the system, install NGINX, copy our HTML file, configure a virtual host, and reload the server. Second, backing up a MySQL database. We use MySQL dump to export the database into a timestamped SQL file. These scripts automate deployment and data protection, core skills for any DevOps engineer. Let's install a LAMP stack on Ubuntu 24.04. This script checks for root access, updates the system, and installs Apache and MySQL. It enables and starts both services, preparing your server for web hosting and database management. Simple, efficient, and perfect for setting up a development or production environment. Let's complete our LAMP setup. After installing Apache and MySQL, we secure MySQL with MySQL Secure installation. Then we install PHP and its common extensions, like PHP MySQL, PHP CLI, and PHP XML. Restarting Apache loads PHP support, and we create a test file using PHP-NFO to verify everything works. Visit your server's IP to confirm your LAMP stack is ready. This is just the beginning. With the skills you've gained at DDevOpsAcademy, you're ready to take confident steps toward a successful tech career. We learn, grow, and succeed together. Thank you for being a valued part of our student community. Don't forget to subscribe and stay tuned for weekly tech episodes. Your journey is just getting started.